Okay, everybody. Now that we've tested our frame buffer setup, our DRM, and we're fairly sure that our setup is working, of course, we're disregarding some errors that are irrelevant in our own context. Of course, you have to go over them and fix them if you're working on a proper product. In this session, we're going to work with the payload of this workshop, which is to port the kernel modules or the adapters provided by TI to have the binary blobs that come with the PowerVR GPU work with the kernel that we are working with, which is the latest stable 4.7.6. So let's get there. Showing on the screen is the SDK provided by TI for the AM335X SoC. What you want to grab is the first entry there, which is TI Processor SDK Linux AM335X EVM3, a lot of zeros, 4. The reason why you want to get this is because of the fact that it provides you with everything that you'd get if you just download the source, plus the file system, which contains the binaries, the userland binaries that you're going to need to transfer to your BeagleBone in order for the whole PowerVR setup to work. And so go ahead and download that. I've downloaded it and extracted it into a directory that I called TI SDK in the workshop directory that we've been dealing with. And well, actually, what would happen is this binary would run and give you a wizard-like or a Windows-like wizard that will ask you to extract, to define the top directory where things are going to be extracted. And I've chosen TI SDK in the workshop directory, and you can download it wherever you want. So I'm going to jump ahead and work from the point of extraction. So here we are with our extracted TI SDK directory with all the stuff we need to actually work on porting the drivers we'd like to port. The first thing we need to do is basically look for documentations, some README files, install files that can give us an idea about how to deal with this SDK. There you have it in the top directory. And you can see that there's a lot of information in here, a lot of files, but we're only concerned with the file or the top directory that contains the source code for the modules, the kernel modules that we'd like to port. So here we are, and we're looking for some documentation on how to actually work with this SDK. Let's install. And you can see here, build system environment variables. Disk image is only needed when you're actually installing, and that we don't need. The kernel directory is something we need for build time. And of course, cross-compile and path. Is there something else here? No. So what we're going to do is basically go modify our environment setup script so that we can have everything we need by just sourcing this file before we go into compilation. So we're going to add kernel directory. Remember, we're doing this because the module we're compiling has to build against the kernel. And of course, we want it to build against the kernel that we're working with, which is 4.7.6. We're going to have to do some stuff we're going to have to modify the kernel to actually work with this thing, but that is a topic at the end. Maybe in about 10 minutes we'll get to that. So there we have build. Now build is a command line argument. So we're not going to add it to our environment setup. So let's go down there to the directory that holds the make file for our, where is it? OMAP Linux. Yeah, that's where we're headed. We still have to investigate the make file because the make file was made to work with the whole build system that is specific to kernel 4.4. So we're going to have to look at that. Target product. So it's expecting some environment variable, target product, to be set. Now, but we need to know what value. We need to know what value to set this variable to. So let's just look at the way it is used. Okay, target product, OMAP 5. So those are everything that comes after filter. Okay, there we have it. TI335X. This is actually the SOC that we'd like to use for this compilation. I'm not sure why this is twitching. It's very annoying. Anyways, anything else? No. So we're gonna add target product, and we're gonna set it to TI335X, since that's the SOC we're dealing with. And this is basically all we need to do here. Let's look around for something else, if there's any LDM platform. Okay. Let's source our environment script. Good to go. Okay. So now we're going to change directory or cd into the directory that holds the make file for our target, which is OMAP Linux. Here we are. So we're just gonna build. So say make, or we want to set the build variable. Remember the command line variable. We're gonna set it to release and see what happens. We're probably gonna get failures because of the fact that, oh yeah, there you have it. And this is the way we're gonna go about this thing. We're gonna just try to make it and fix any errors that come along the way. Implicit declaration function, page cache release. Let's copy that. We're going to go to LXR. Now the way we're going to do this is by basically comparing this identifier, page cache release, between both 4.4, kernel 4.4, because that's the, okay, let's just go straight to that and do an identifier search. Yeah, between the 4.4 kernel, which is based on which is the, okay, it doesn't exist in 4.7. But it exists in 4.4. Let's see the definition there. Okay, it's a macro that is just defined. It's just pointing to put page. So we're going to go to 4.7 and see if we have put page. Of course we do. This is a famous memory management API. So put page. This means that we can just substitute every occurrence of page cache release in the source code of the driver we're compiling, or the module. We're going to substitute every occurrence of that with put page, basically. So we're just skipping that. This is the line. Page cache release. There it is. So we're just going to remove this and put page. And we just go run make build again. Or should we fix? Okay, let's run build make build and just fix only one error per compilation or per run. There we have it. Where are you? Okay, you're in this function. We're passing argument 1 of get user pages makes integer from pointer without cast. Okay, that's what the compiler think, but as usual, this would be an API change between kernel 4.4, which this driver is built against, and the kernel we're working with. We're going to look for it in kernel 4.7, and there we have it. Get user pages. It exists. So what changed is the way you call it. It still exists, so it's either the way you call it or the functionality of it. So let's just let's copy it, and we're going to make a buffer file here just for us to visualize the differences and see what we can do about it. Okay, so let's see the equivalent of this definition in kernel 4.4. Oops. We're looking for get user pages. Okay, we gotta get the same file. Okay, there it is. You can straight away see that the signature is different. Let's just put it here for comparison. Oops. Let's just label these so you won't forget. So in 4.7, that's what we have, and in 4.4, this is what we have. So let's compare this. Long start, not first, not second, third. And it's the same type. And then unsigned long number of pages. And right, this is a flag. That's another flag for struct pages. Okay, so they're almost identical with the exception of the first two arguments, which are context related. Let's look around for something else that looks like it. Okay, let's just go and see how it's used and how the usage changed between the two kernels, right? So because if somebody is using it, they must have fixed it along the way, since the code is still. So here's a random one that we have. Let's just take this. And we're going to see this in 4.7. Remember, the other one is in 4.4. So we're going to look for get user pages. And there we have it. Let's just align the whole thing so we can compare. Okay. There you have it. They're basically dropping the first two arguments. Yeah, see, this argument aligns with the third argument. The third argument over there. And the rest is the same. Okay, so they're just dropping the first two arguments. Maybe we should just follow. Okay, before we do that, let's make sure that this is what actually happens, that everybody just drops, because they may be doing something, they may not be following the rules. So let's just go to our kernel. What we're going to be doing is basically looking at the log files and tracking down the commit message, or the commit on the patch that changed this. There we have it. It's in here. And we're going to look for, what was it? Get user pages. There we have it. The old is that, the new is that, and then what's up here? So both these variants worked at the C level. Okay, I see the fact that they dropped this API. That doesn't look like something that concerns us. Here do all the things again. Convert new 6 argument. Okay, I can see the dropping of it. If I had to guess, this is related to the context. So if you're calling from the current task's context, you don't need to pass it. No, none of that. So let's just next. Let's see the exact point at which it changed. This is not it. So okay, this is okay. Okay. Oh, there you have it. With or without non-remote version used remote style access. Okay. So it is about the context from which you're calling the API. To understand what reputation should be enforced. This is irrelevant. This patch introduces a new variant, which is remote, which is a replacement for is called from non-current tasker. Yeah, okay. So it is actually for that purpose. So it's I think it would be safe for us to just drop the first two arguments from the source code of the module we're compiling. Let's find the function, or the actual call. And let's just look for it. Okay, user pages. There's our call. So we're just gonna drop the first two arguments. Okay. Let's come back here, make build release again. We hit another error. What argument is it? What is this? Incompatible types. VM insert mixed. Okay. PFN. I am familiar with it. This is the page frame number. I think there was a new type that was introduced. But this change is not very intuitive to me. It's not very consistent because I've been through it before. It does not change all the interfaces that use PFN. It only changes the one, the virtual thing. You can see that this is a structure that was introduced, a type definition, and its gut is only an unsigned long value. You can see that we're going to go check out the call and see if it would match. Of course it should, otherwise we'll be in trouble. We want to see if the type of the variable they're using instead of the PFN type is a match, and that it's okay, unsigned. This is strange. It should be 64. There's an if, not define PVR. Defense. Okay. This is. Let's look at this. Image unsigned integer pointer type. IMG. It's imagination, I guess. Okay. This is a script that I wrote. It's a bunch of seds and grips. I will just go ahead and find every mention of that in the current directory. So let's vim into this. It looks like the type, IMG types. And let's look for it. There you have it. Type diff unsigned integer 64. So it is a match. So basically it's safe to just substitute the whole thing with this value. The call that actually failed, we're going to have to substitute it with this value. Okay, we're going to add this guy and follow down and see where this thing's actually getting. There. That's the assignment. So we're not going to touch the assignment, but we're going to get the value of the assignment and set it to the value member, the only member of the PFN type. We shouldn't have to cast it, of course. Anyways, but this doesn't look right. Is this the line number at which we got the trouble? No, it doesn't look right. Let's see which line. 790. 790. There it is. It was in VM insert. So we're going to do this. And we're going to go up here and define it in the within the function kbfn. And we're going to look for the stuff we did here. We don't want this stuff, so let's just take it down where it's actually needed. And then we're going to go up again, delete this, delete this. If it didn't fail here, it means this path is not taken. So I think we're good here. I think we're good here. Note that we've changed only the minimum. Okay, let's go again. Okay, this is a fast error, a fatal one. Okay, Linux platform data SGX. This is a missing file. See, no such file or directory. This is obviously a missing file. So this file existed in TI's kernel, but it does not exist in our own kernel. Let's go see. Platform data. Is it OMAP SGX or something like that? It's SGX OMAP. There you have it. This file does not exist in the mainline kernel. Naturally, because it's an SGX specific file, but we're going to have to copy this guy into our own kernel. And whenever you're copying a header file, always remember that if it does not include inline definitions, static definitions of whatever it has in its guts, the header file, there's bound to be a change within the kernel source that makes use of that header file. So we have added this, and we could have just went ahead and compiled, but that would have caused probably runtime errors, possibly panics, rogue pointers and stuff. So we have to go into the kernel and actually crypt this. Okay, there we have it. We need to know where this structure is being used within the TI kernel. And you can use some intuition here and expect it to be somewhere in OMAP 2, Mac OMAP 2. So we don't have to check the whole kernel tree. We could just, okay, let's just go to Linux. Where is that? Port support, Linux. This is TI's kernel. We're looking for Linux 4.4.12. And we're going to cd. We're going to cd into, where is it? Okay, arc arm Mac OMAP 2, yeah. And we're going to look for the usage of the structure that we just copied from the header file, the SGX OMAP header file. ch. Okay, there we have it. pdata quirks. That's the file that makes sense. We're lucky that there's only one file used in it, because if we had too many, that would have been a hassle. So let's see how this guy's using the SGX structure. Come on. SGX. There. It includes the platform data SGX OMAP header. And you know what? At this point, I'm going to go use compare in order to better visualize the differences. And yeah, it just makes our life easier. So we're going to find the thing we were just looking at. Projects, workshop, TI SDK, board support, Linux, ARC, ARM, Mac, OMAP 2. There we are. And we're going to compare it to the kernel we're working against, or we're compiling against. So it's our Linux 4.7.6, 7.6, yes. Are we sure of this? pdata quirks. Okay. So let's just compare the files. So the one to the left is the one that uses SGX OMAP, so that's TI's kernel. To the right is our own kernel that does not have that yet. So we're going to work on, look at that, anything that has a reference to AM33 whatever is our thing. We're going to ignore the other stuff for now, specifically the PRU and all that good stuff, because we don't need them for this thing. Mac. But again, if you're working on a product and you need that, you're gonna have to follow the same procedure to actually get to it. Okay, let's add our include. SGX omap.h. So now we have that structure, and we're going to look for this. See, the problem with compare is that you can't copy. Okay, if defined this. Okay, it's basically setting the stuff inside the structure. So what we're going to do is we're basically going to come here and we're going to go to TI's kernel and basically have a better where am I? Okay. We're in bone black, so we need to go to TI's kernel. This is getting confusing. Mac 2 and pdata quirks. And that's it. So this is where we're going to compare using compare, which is the UI thing, and we're going to copy from this file. Where is the thing? There you are, config. Okay. So we're going to copy this. Let's set no number so we can comfortably copy stuff. And we're going to take this whole preprocessor define, or if defined. When we place it, where are they placing it? Okay, right below TW, whatever. Format. Right. Let's compare some more. Platform data, that doesn't concern us. This here is OMAP, IOMMU. This could be, we don't care. This guy is OMAP 3, so nobody cares. This is OMAP 3 as well. Let's go more. Typo fix. Okay, OMAP 4. Yeah, not ours. Okay, this looks like ours. But it's PRU, so we don't care. This isn't ours. Neither is this. What is this? Timer. That is. Okay. Not ours. Not ours. Okay, this is ours. So whatever's in here, we need it. Again, we're ignoring PRUSS, PRU subsystem. We're only going to take this thing. There we have it, SGX530, this line. So we're going to copy it. Move it over to our own kernel's pdata quirks. We have to match the line. Where was it? Here. Okay. I think we're good. Let's go back to compare. There's a lot of stuff here that they're not really our thing. This is very close to, but we don't care. Yeah, we don't really need this because it's not our configured SOC. Another type of fix. I guess that's it. We're done. Okay. Let's go back to our compilation. Let's run make build release again. Going good. No errors so far. And 2 modules. Okay. We're done with the process of porting. We still, of course, have to go through the userland binaries. That's actually a more complex process since we don't have access to the source code. But here are the modules. This is actually the module we care about. The other one is offer class example. I don't really know what that's used for. And let me show you the thing from like in a more straightforward way. Go to board support, extra drivers, TI, this guy, Eurasia, binary, K-build. Okay. We have those guys. And coming next is basically making our kernel or initializing our modules, installing our modules in our file system using the kernel. So make install modules. And then we're going to start transferring userland objects, libraries and binaries, and those two kernel modules that we just built to our kernel. I hope you guys enjoyed, and see you next time.